Every year, the Environmental Protection Agency (EPA) collects data on fuel economy. With rising gasoline prices, consumers are using these figures as they decide which automobile to purchase. We will look at two-seater automobiles, many of which are sporty vehicles. Based upon the latest 2007 EPA sample of 71 vehicles, the average combined city and highway miles per gallon is 20.38 miles per gallon. We wish to test the hypothesis that the combined city and highway miles per gallon (MPG) of two-seater automobiles is greater than 20. The standard deviation of all vehicles is 4.7 miles per gallon. The variable that we are interested in this case is miles per gallon, and we let x be the number of miles per gallon. Now, the hypothesis test is the test about the population, so it is the test about all vehicles in this case. Specifically, we assume that this is all two-seater automobiles. We were given that the standard deviation of all vehicles is 4.7 miles per gallon, so sigma is known. Sigma equals 4.7. From the sample of 71 vehicles from this population, so the sample size n equals 71, they computed that the average miles per gallon is 20.38 miles per gallon, so x bar equals 20.38. For this hypothesis test, we test the claim. So this is the initial claim about the population here. The claim is that the average mile per gallon is greater than 20. Translating this into symbolic form, the average mile per gallon, mu, for the population, strictly greater than 20. And that is the initial claim. Now, since sigma is known, sigma is given, the standard deviation of the population is given, we will use the z-test. The first step of the hypothesis test is to state the null and the alternative hypothesis. So this is the hypothesis step. To write the null a sub 0 and the alternative a sub a hypothesis, we first write the opposites of the initial claim in symbolic form. The initial claim is that mu is greater than 20, and the opposite of greater than is less than or equals. So the opposite is mu less than or equal to 20. The statement that does not have the equal sign is the alternative hypothesis. So the alternative hypothesis a sub a is mu greater than 20. And the null hypothesis is the statement of indifference, so it always have the equal sign, mu equals 20. The second step is to collect the data and summarize the data. In this case, they collected the data for us already, and in fact, they summarized the data already. The sample size is 71, and they computed the mean also. What we need to do now is to compute the test statistics. Specifically, we're going to compute the test statistic z for the test for the population mean. But before we do that, we might want to check the condition to see if it is safe to carry out the test. This is the test for the mean, so we just need the distribution of mile per gallon to be normal. In this case, the problem did not mention normality. And so we check the alternative to see if the sample size is greater than 30, and yes, this condition is met. The test statistic z is z equals x bar minus mu over sigma divided by the square root of n. And the reason why we check the condition, it is because the hypothesis test rely on the sampling distribution. The alternative hypothesis tells us that this is the right tail test because it is greater than. And so we're looking for this z value here. X bar is the sample mean 20.38. Mu is the null hypothesis. Technically, it is mu sub 0, but remember, mu sub 0 is the numerical value here, which is mu. Mu equals mu naught. And so mu naught is 20. Sigma is given 4.7 divided by the square root of n is 71. Plug this in a calculator, we will get 0.681 for the z-test statistic. Z equals 0.681. Next, we compute the p-value. The p-value is the probability that z is greater than 0.681, z greater than the test statistic. In this case, again, it is the right tail test because what we see in the alternative hypothesis. Using a calculator or even the table, we find that the p-value is 0.2479. To find the p-value for the z-test, we will use the normal calculator. In this case, we will use Desmos.com. With Desmo, we type normal, DIST, for the normal calculator. We will need to specify the mean and the standard deviation. This is the standard normal distribution, so the mean is 0 and the standard deviation is 1. With the shaded region, the left or the minimum value is 0.681 and the maximum is infinity because there is no max. And so we input the minimum 0.681 and leave the maximum alone. There we have it. The p-value is 0.2479. To draw the conclusion, we would compare it to alpha. Alpha is the significance level, and alpha is not given, so we would use the standard 0.05. How does the p-value compare to alpha? 0.2479 is greater than 0.05. Since the p-value is greater than alpha, we would fail to reject the null hypothesis. Now, if we fail to reject the null hypothesis, meaning we support it, then we would reject the alternative. The initial claim is the alternative. Remember that the original claim is the statement that the average is greater than 20. So this is the original claim. We support the null, meaning we cannot support the alternative, but the alternative is the original claim. This means we cannot support the original claim. In the conclusion, even though the hypothesis test is about the null hypothesis, whether we reject or fail to reject the null hypothesis, but it is not enough to simply write we reject the null hypothesis or we fail to reject the null hypothesis. In this case, we analyze it. We see that we cannot support the original claim. And so we need to write a statement that would make sense in that context. And so we add the statement, there is not sufficient sample evidence to support the claim that the average mile per gallon is greater than 20. This means we cannot support the original claim. And this is the fourth and the final step in the hypothesis test.